past month and for the upcoming couple of weeks, we're going to be focusing on additive manufacturing in general. And for those of you that don't know it, I'll leave it for the experts themselves to run you through what they've been focusing on. But it's a topic which has been really picking a lot of steam, not only with us in our ecosystem, but also and for the UAE in general, especially for the alignment with the UAE national strategy at the Advanced Industry Ministry of the Advanced Industries. So today we have Mr. Olivier from Siemens and Mr. Tibor from Dynamics. Is that how you pronounce it, Tibor?
I think I'm on mute. Dynamics, but it's good. Yes, absolutely.
I can make it sound a bit more exotic sometimes. Thank you for everyone who's tuning in. I know we have a very recurring fan base and always a growing fan base of people who would love to learn about new things. So this session will be kicked off with a pre-recorded video of our CEO, His Excellency Hussein Mahmoudi, talking about the Sharjah Research and Technology Park and what we've been up to over the past 2 years, followed by Mr. Olivier and followed by Tibor, and then we'll wrap up with a quick Q&A discussion. I've already got my questions before you gentlemen even spoke, so I'll be the one who's going to be bombarding you later on. If I'll give the cue. So to continue the engagement, I know everyone's been tuning into webinars for so long, so it sometimes gets mundane. So we're trying a new format here, and the audience is going to be also the first to be tested out. I think you should unmute. Everyone's been tuning into webinars for so long, so it sometimes gets mundane. So we're trying a new format here, and the audience is going to be also the first to be tested out.
The Sharjah Research and Technology Park is a brainchild
I think you should unmute.
Of enforcing the role of innovation and knowledge economy.
Everyone's been tuning into webinars for so long, so it sometimes gets mundane. So we're trying.
Tarek, we don't have the sound when the video is playing.
And the economy.
Yeah, I figured. So I'm just seeing if this is.
Our fourth objective is really to invest in the future. We at the Sharjah Research and Technology Park, we identify.
Tarek, we don't have the sound when the video is playing.
Yeah, I figured.
Visual experience to promote your business.
Our fourth objective is really welcome to the Sharjah Research and Technology. We at the Sharjah Research and Technology Park, we identify a gateway for innovation and business growth. The Sharjah Research
and we don't have the sound when the video is playing.
Yeah, I figured.
Visual experience to promote your business.
Our fourth objective is really welcome to the Sharjah Research and new opportunities. We at the Sharjah Research and Technology Park, public sector identify gateway for innovation and business. It's a reflection of the leadership. The Sharjah Research
and we don't have the sound when the video is playing.
Yeah, I figured so.
Experience to promote your business.
Our fourth objective is we welcome to the Sharjah creating new opportunities. We at the Sharjah Innovation Park publicly identify and innovation and business. It's a reflection of the leadership. The Sharjah Research
Yeah, I figured so.
Experience to promote your business.
Our fourth objective is we welcome to the Sharjah creating new opportunities. We at the Sharjah Innovation Park publicly identify and innovation and business. It's a reflection of the leadership. The Sharjah Research
Yeah, I figured so.
Experience to promote your business.
Our fourth objective is we welcome to the Sharjah creating new opportunities. We at the Sharjah Innovation Park publicly identify and innovation and business. It's a reflection of the leadership. The Sharjah Research
Yeah, I figured so.
Experience to promote your business.
Our fourth objective is we welcome to the Sharjah creating new opportunities. We at the Sharjah Innovation Park publicly identify and innovation and business. It's a reflection of the leadership. The Sharjah Research
Yeah, I figured so.
We at the Sharjah Research and Technology Park, we identify companies and we vet them and we invest in these companies and we scale them up. Our objective is to create enterprises that will create economic, sustainable business. We at the Sharjah Research and Technology Park focus on 6 main subjects. The first one is water technology. The second one, production design and architecture. A third one is mobility, logistics, and smart cities. Fourth one is healthcare and digitization. And fifth one is renewable energy. And last but not least, environmental technology and circular economy. These are the 6 areas we focus on. And these are the 6 areas that we believe our colleges, our private sector have a competitive edge to grow and develop. We believe in triple helix. We work with government, private sector, academia, and non-for-profit organization to develop our ecosystem of innovation. We have launched research activities with universities, and we're trying to commercialize this research. We also engage with government and implementing best practices when it comes to artificial intelligence, blockchain. We launch sandbox with ministries, and we work with businesses as well in developing and commercializing technologies that will make them more sustained and more competitive going forward. We pride ourselves at the Sharjah Research and Technology Park to be able to attract some of the leading technologies into our park, whether we are talking about 3D construction or additive manufacturing or agriculture technologies or photovoltaic R&D centers or transport and mobility technologies or mixed realities. We pride ourselves to be part of a 47,000 students ecosystem at 22 universities and education institutions and more than 2,000 PhD holders, all in the same place within the vicinity of the technology park. Since its inception, the Sharjah Research and Technology Park managed to attract global players, regional players, and local players. We pride ourselves to work with international companies like GE, like Intel and Nokia, for example. We work with GE on additive manufacturing. We work with Intel on solution related to educations and reskilling. And we work with Nokia, for example, on IoT labs and other things. We also have regional companies leading in additive manufacturing like Amensa. We have also mobile fueling companies like Kafu, and also we have companies in health like Nipta. We also have local startups are thriving and really defining the way forward. Since an inception at SRTIP, we believed to have a global vision and regional mission. We believe in partnership, sustainable partnership. That's why we work with countries, with academic institutions, with science institutions, and with UN-led organizations as well. The objective is to develop sustainable partnership and a win-win situation for everyone. We developed the Sharjah Research and Technology Park based on best practices. And its start, we managed to benchmark Sharjah against 9 other cities around the world, from Boston to Marseille to Shenzhen to Bangalore to Hyderabad to Philadelphia. We looked at 6 main innovation criteria, like market and investment, inter-firm activity, knowledge and R&D, human skills, infrastructure, And we looked at these things and we benchmarked with other nations around us to see where Sharjah is vis-a-vis this nation and learn from these activities as we go on. Here are some examples of the bright technologies that we are developing here in Sharjah. We pride ourselves to have the largest or one of the largest transport and logistics innovation center in the world. We in Sharjah developing next generation technologies that will be promoted in this region and will become an integral part of the mobility solution in the Middle East. We also pride ourselves to have significant investment and technology development in hydroponics and aquaponics and agriculture technologies. We believe that the Middle East food security insists that we develop these type of technologies, and we work hand in hand with the private sectors, with entrepreneurs, and with academia to develop these technologies here. Third, we also developing a photovoltaic R&D center. Our main is to promote renewable diversity and bring new source of sustainable diversity to the energy mix when it comes here in the park. We pride ourselves to launch Energy Innovation Hub, a regional platform to engage and attract innovations into this region and link them to the industries of energy within the region. We also pride ourselves at the Sharjah Research and Technology Park to host one of the largest makerspace in the UAE, the Sharjah Open Innovation Lab. This lab dedicated to entrepreneurs, to faculties, to companies to come and co-create and co-innovate the future of technologies at the park. We develop and promote this soil lab by engaging with different players, whether you are an investor or a company or academia. They all come and co-create and create businesses and enterprise out of this lab, which features cutting-edge technologies in textile technologies, electronics, metal, 3D technologies, and others. For SRTIP, collaboration with academia is an integral part of our work. We work with universities in the UAE and around the world. For example, the American University of Sharjah is one of our key partners, and we work with them on three main areas. One around IP and commercialization, entrepreneurship and development of science, employment and internship, and also lab exchange. We believe to have an innovation, we have to develop human capital and develop a strong link to academia and academic institutions. Here, I would like to share with you some other examples of the innovation we have here. We've managed at SRTIP in collaboration with academia and industry to create a fantastic footprint, a regional lab for construction of 3D materials. So we have today printed many houses using 3D technologies and using collaboration with education as well. Another example of what we do is we develop IP, intellectual property, and commercialization of the IP, and the topic, for example, here is conductive concrete. Another example of R&D is we are developing an exoskeleton technology that can apply for healthcare sector and also apply for industry within construction as well. And we do this in collaboration with academia and in collaboration with the private sector as well. The Sharjah Research and Technology Park also thrives on developing an ecosystem. I have spoken about the Middle East Energy Innovation Hub. This is a platform to develop new innovation within the energy sector. To be able to conduct our work at SRTIP, we have developed a comprehensive ecosystem that includes events and themes like the Women in Technology, promoting circular economy, and launching various accelerators. Our flagship accelerator is the Sharjah Advanced Industry Accelerator. We pride ourselves to be a home for the Middle East North Africa Innovation Technology Transfer Summit. We would like to position Sharjah as a platform for technology innovation and technology transfer in the whole Middle East. And we work with scientists, with science institutions, academia, private sector to be able to do this. In addition to that, we run a series of events at the Sharjah Research and Technology Park. These comprise webinars, exhibition, conferences that allow businesses and partners and tenants of SRTIP to engage and grow and develop their businesses and build up strong network with investors, businesses, academia, and government. We also launched the Sharjah Angel Investor. The main aim of this angel investor is to create funds and make funds available for startups to come and grow out of Sharjah. We also host many delegations, international delegations, throughout the year at the Sharjah Research and Technology Park. We host a lot of webinars, and we aim to do more of these webinars to cement relationship with countries, with industries, and with different players. Sharjah Research and Technology Park also have fantastic facilities for exhibition. We host many exhibitions and conferences at the park, and we aim to continue doing that going forward. This is a summary of the Sharjah Research and Technology Park. I hope you enjoyed the presentation. We look forward to working with you. We will look forward to partner with you and grow with you. Thank you.
Thank you for your patience. That was a bit of a turbulent start. Again, you guys were the first testers of this new feature, so thank you for being our test subjects. Gentlemen, thank you for also noting out for the audience members that put it to our attention, and to Olivier, thank you for even finding your voice looped out over and over again. So I think we can give the floor to Olivier for him to upload his presentation and talk about what they've been up to.
Yes, hold on a second. Let me share my screen. You should be seeing it now. Please give me a...
It's on. There we go.
Okay, perfect. So first of all, I would like to thank Tarek and SRTIP, first of all, to give us the opportunity to talk about our experience in the field of additive manufacturing. So thank you for that. So as we discussed earlier on, I will be giving you a pretty hands-on presentation on additive manufacturing. So I will be starting with a couple of examples, a couple of applications where we as within the large Siemens group have used additive manufacturing. Some concrete examples highlighting the technical aspects, but also the economics aspects, which are of course important and often the starting point in someone's AM journey to find the right application and to find and build a business case around that. So and then after I will talk about the technical aspects from the digital point of view. So I'm to introduce myself, I'm part of Siemens Digital Industry Software, so the software division of Siemens, and I'm the portfolio executive for AM for the Europe, Middle East, and Africa. Okay, so I will be speaking from the software perspective on the technonomics of additive. So let me start my presentation with an example. So it's a short video. What you see here basically is the tip of a burner, which is the application is a fuel refinement system. You see here that we're heating up the tip of the burner because these are very high temperature applications, and up to a point where temperature could have melt the metal. So this is, of course, and I will show that in a minute, a tip has been optimized through or redesigned and optimized for additive manufacturing. You see what this gentleman has done. We're talking about, I think, 900 or 900 degrees from what you see here. It's been cooled nearly instantly. So I will be showing what we have achieved in terms of cooling optimization, and also, of course, the economics aspect for this specific industry, for this specific application. So basically, this is the entire part that you just saw. We just showed the tip of it. So it's a pretty complex part, pretty large. It's 3.4 meters. With many disadvantages. So a large assembly system. So with very high manufacturing costs. Assembly systems means a lot of parts that need to be assembled, that need to be welded or bolted together. So this, of course, has an important effect on the supply chain, because you need to manufacture those parts separately. The size, it's pretty big, and you will understand why in a second. So that is the starting point. And also, what's important is, of course, the design and the complexity of the part that we have optimized for additive manufacturing and the tip of this burner, because you need to cool it down as much and as fast as possible. So you see the design with lots of cooling channels. This is the standard design, the initial design, sorry. And we will have a look in a second at the optimized design with additive manufacturing. So what is the result? I'm not going to go into the technical details. That's not the purpose of today's presentation. But you see, we went already in terms of size from a 3.4 meter part to a 1.7 meter part. That is 50% decrease in size. So that is obviously, really important. And you will also see at the bottom of the part a funnel bulb. So basically, the inspiration of the redesign process came from a natural design, basically. And as you can see in the center, the optimized design, or at the right, bottom right picture, this is extremely complex, right? And it's only manufacturable through additive manufacturing. So that is something that we are trying to highlight here. Optimization, improvement of your parts, of the applications that you're looking at for additive, are often only possible through additive manufacturing. So this is the tip, as you can see, with the flow of the fuel, and then of course the cooling channels intertwined. This is impossible to manufacture with standard production techniques. So basically, to highlight the advantages of using additive in this field are pretty obvious. As you can see at the bottom, on the right side, very simplified mounting. So to put your part within the assembly of the entire installation. In terms of manufacturing, also very interesting and unique advantages. Reduction of 50% of the parts. So this has an effect beyond the part itself, but on the entire supply chain. In terms of welds, because obviously when you go into a high temperature weld, a high temperature application, welding and mounting and assembly is a cause of stress, thermal and mechanical stresses. So this has been reduced also by 50%. And of course, getting the AM part within the system is also much simplified, because the part is smaller and with the different fewer parts that are getting together. These are the technical aspects. In the business aspects, I mean, it's pretty straightforward also. You can imagine what are the advantages of this. What matters here is that you want to get your new designs, whether it's plastic or metal, you want to get them as fast as possible to your customers, to reduce time to market. You can do design iterations very easily and get your part, your end part to your customers, deliver much faster. And of course, in terms of, like I just mentioned, design, optimization or new design, so innovation cycles are also made much shorter. And of course, here, this is also an important aspect, because when there is a downtime in the oil and gas industry, and you will see it with the other application in the energy sector, you want to reduce the downtime of your installation. This makes your the repair time or the downtime is reduced to the maximum, because you can manufacture those parts or spare parts in a much faster and efficient way. Okay, so this is the first example. The second example goes to another company within the Siemens group. It's now called Siemens Energy. Those are the huge the huge turbines that Siemens Energy is making. And our colleagues at Siemens Energy are using additive manufacturing day in, day out. There are a couple of factories. The main one is in Sweden, where we have about 20 or 30 metal printers making spare parts for those turbines. And this is the example I'm going to use and show you in a second. Okay, so basically you see the turbine, this model on the right side. There is a circle or a series of about 12 burners, gas burners that you can see. And those burners have been replaced in time after, of course, lots of iteration and certification processes have been replaced by additive manufacturing parts. What you see here is on the left side is the conventional design, and on the right side is the additive manufacturing part. So you see the one that is a bit more shiny. This is a part that is assembled. It's an assembly of 13 machine parts with 18 welds, very high temperatures, that are submitted to very high temperatures, with specific coating linked to this application, which means you can imagine a very long lead time to manufacture. Okay, so several years ago, Siemens looked at how can we use additive manufacturing to optimize first the performance of the part, but also the economics aspect. So through different iterations, because that's one of the key issues of additive manufacturing, we did really an assembly simplification, and a pretty drastic one, as you can see on the center picture. So from 13 machine parts, we went to one single part. So which means that the part that you see on the right side, which is on the right side of the shiny part, is printed from top to bottom. Initially, we had started by only printing the tip of the burner, because those were optimized with latticed structures because they needed to be cooled down a bit like the previous application. But today, these parts are manufactured by the hundreds every week, as in one single part. So of course, you can imagine already the effects on the supply chain, because you don't have to stock and manufacture independently those 13 parts. As I said, the design has also been optimized in a way that is only possible with additive manufacturing, through internal cooling channels, through using lattice structures to really optimize the flow, but also the cooling of the entire part. So from 26 weeks of lead time, we go to 3 weeks lead time, which means in 3 weeks time we can print the part, do the post-processing, and have it delivered to our customers to do the maintenance of their turbines. What is also important is the weight gain. This is a static application, so weight is probably less important than an application that flies in a UAV or in a plane, for example. But nonetheless, it's very important. Here you can see there's approximately nearly 50%, maybe a bit less weight gain. So that is also one of the advantages of additive manufacturing. Okay. So going to the more technical aspects from a digital point of view. As I said, I'm rather a software specialist, and software for additive manufacturing is often one of the topics that are being tackled the latest. Once you're looking into additive manufacturing, you often look at identifying the right application, making sure you find the right application, and then of course based on that you look at which machine, which material, but then you realize that actually the digital thread, the digital tools, or the process, digital process is actually also very important. Here, this is an overview of what at Siemens we see day in, day out from a digital perspective. What is the current situation? So you need different steps in this process, going from the part from the design to the part. And of course, in between, you have lots of different steps. You have the design aspect, you have the simulation aspect, depending on the material, plastic or metal. You want to see how your part will be printable, if it's printable. You need to go to another step, which is getting your part on the machine to prepare the platform, supports 3D nesting, and so on, depending on the technology again, all through getting the end part in your hands, making sure that it's within your quality tolerances, and before shipping it out to your customer or to use it in your industry. So of course, once you're looking at scaling from a small prototyping activity to a more industrialized level, this kind of workflow is very difficult to control, because for each step you need different kind of tools. Those tools are not connected together. They're often from different vendors. Different file formats, of course, because you go from your CAD to the STL file format. STL is a pretty old file format, but it's still the standard in the industry. And then, of course, let's say you use metal additive. You want to see, do I use simulation software? Because I want to see if my part will be printable. Every time you need to go in and out, and you need to convert the data. And additive being still a very iterative process, this gets really difficult to manage. You're not sure to be printing the latest design or the latest iteration. It costs you time and, of course, money. And of course, having this disconnected process flow is also very expensive, because you have many, many different tools that you need to manage from the beginning to the end part. And also an important aspect is conventional thinking. One aspect that you absolutely need to integrate, which is difficult to have in this disconnected flow, is the and most importantly at the design aspect. You don't design for additive as you design for CNC milling or standard production technology. So you need to integrate certain design rules for additive manufacturing, and those design rules vary from the technology that you are using, whether it's plastic or metal, and of course the many technologies in each of these technologies. So the way we address that within Siemens, the big Siemens family, and also from the digital aspects, from the software aspect, we like to use as an overall vision the concept of the digital twin. So basically, we explain that from the product to the production and even beyond, you can really simulate every single step of the process. So the digital twin of the product, of the production, and of the performance. And this enables you to really optimize your AM process from the start. And what is important here is this loop that you see, because that's what we call a closed loop manufacturing, which means that within the same environment, within the same software tool set, you can really go from the start, from your CAD design to the end, to the part itself, and even beyond. If you look at industrializing the process, we can also look into topics like line simulation, factory simulation. So basically, how do you position the machine, the depowdering station, etc., because at the end, this will affect the cost of the part. But this is already for companies who are ready to industrialize the additive process. But the digital twin of the product and the production is also applicable for companies who are starting, who are looking at adopting or are in the early stages of their AM process. So going back to the initial slide where we saw the complexity of the digital thread, this is what we mean by an integrated solution. So we go from this disconnected process flow to this integrated solution or integrated flow from design to the part itself, and even beyond with automation and data management system. So, and here you will understand what I mean also by having an integrated system, and why this is important also for the designers, because we talk about different aspects. We talk about topology optimization. We talk about using lattices. You've seen the example of the burner where the cooling tip has been optimized through lattices. That's only possible with additive manufacturing. At this stage, the designer can already check, okay, is my part printable? Because normally what you do, you have your design, you send it to your supplier or to your internal AM unit. They will put it on the machine. They will maybe print it and fail, or just say it's not printable because your part is hollow. There are overhang angles and so on and so on. So at this stage, having this connected system, you can really check from the start if your part will be printable or not. And then, of course, we go to the manufacturing process. I'm not going to spend too much time here, but of course, we're open for discussion or for further information later on during the Q&A. Build preparation, the build simulation. So I want to make sure that if it's metal or plastics, but today it's mainly based towards metal, to say, okay, I don't want to print 10 iterations. I want to print, like we say, first time right, because my machine is expensive. I'm using titanium. It's the kilo of titanium part is also expensive. So I want to optimize my printing process by simulating before the printing happens. And then, of course, we go beyond by, okay, how can we make sure that the part is removed from the platform, the supports are removed optimally without damaging the part. And then, like I said, for users who are ready to scale up multiple machines, different production sites in the same country or globally, you need tools to connect those different activities, different sites all together. So that is for us the answer to these bottlenecks that we have gone through very quickly a couple of slides ago. And of course, the last aspect, technically, is to say, okay, what is my application? In which industry am I? Which parts are possible for additive manufacturing? Because this will, of course, define which technology I'm going to invest in, or I'm going to work with my subcontractor. Okay, so through the Siemens digital solutions for additive manufacturing, we can of course connect to the main industrial AM technologies. We talk more and more about DD, yeah? So it's rather production of metal powder, which can be used to make new parts, but also for remanufacturing, yeah? So repair of parts. EBAM, or we call it also wire arc additive manufacturing. FDM, probably more familiar with those technologies. And then the main industrial ones, selective laser melting, MGF, that is HP related technology. So why is this important? Because of course you need different skill sets, you need different solutions, different software, depending on the AM technology you're going to use. So there isn't one solution for all. You really have specific needs in terms of support or nesting or the likes. Okay. So also what we talk, you saw the first slide, and this is going to be the end for me. We talk a lot about industrializing additive manufacturing and moving from prototyping to industrialization of additive. I've mentioned that we are the first users. Basically, we say we drink our own champagne, meaning the skill sets, the solutions that we talk about, and the examples that we use, they come mainly from a very strong experience within the Siemens Group. And today we can show the AM community and our customers what it means to work with a company like Siemens with the different tools or the different services that we have. But that's not the purpose of this call, because we have been doing that for a long time. And the gas burner and the turbines is a good example of that. Last point, just for the conclusion, sorry. If you have any questions, we're really we'll open the Q&A at the end of this call. But Siemens is represented locally in the UAE and also in different countries in the Middle East. So we can get in touch directly or via our partner in the UAE, which is Indish Technologies. So that's it for me. So I would like to thank you for your time and the opportunity to speak. I guess now the floor is to Tibor, and we'll get in touch during the Q&A at the end, I believe.
Thank you so much, Olivier. That was extremely insightful, and I shall hand over the floor to Tibor. Just making sure that we can hand over.
Eric, are we ready?
I don't need to stop sharing. Yes, stop. I click on stop sharing. So now I think you should be able to share your screen, Tibor. Sorry.
Thank you so much. Well, first of all, thanks for the opportunity to share some insights and learnings on the techno-economic side of additive. If you will please allow me, I think also after the presentation from Olivier and Mr. Amaoudi, I think I would like to give you a little bit in a minute and a half, just not hearing me, but just a short animation about what it is that we do. I think we take a slightly different approach. For us, additive is relating much more to all the benefits it can give to a supply chain, and a supply chain of a manufacturing company, but also of a maintenance group, for example, in oil and gas, or in any other critical service or other industry. So if technology helps, and of course it will, I will just share a short animation with you, and please interrupt if something is wrong with the audio. I'll probably hear you guys. Hang on. So.
The screen is up for us, Tibor. We can see it, so you can go ahead.
Perfect.
How can 3D printing help me optimize my supply chain and mitigate risk as a result of a pandemic or severe supply chain disruption? Use 3D printing as a service to digitize your inventory and eliminate parts of the traditional supply chain. Go from mass production and storage to part digitization and manufacturing on demand. From complex global logistics to localized production closer to the end-use location. Dymanex takes you from data and actionable insights to parts delivered using a single end-to-end platform. Select the right parts to digitize, applying sophisticated machine learning on supply chain and technical data. Collaborate with your colleagues to review your designs. Our end-to-end platform supports your quality approval process every step of the way and also performs the part tests. Once your part designs are approved, you can place orders on demand. They'll be routed to the best partner in our global network according to your specifications and needs. Next, we deliver the parts to your doorstep or end-use location. The results? Elimination of tied-up working capital, no unneeded logistics, 50% faster lead times, and a solution to demand unpredictability. Learn more at dymanex.com.
So thank you. Yeah, this just make me sure that yeah, I think voice-wise we're back, and I will share my screen now for the presentation. Okay. Yeah, so this was a quick introduction. I think unlike Siemens, I think everybody knows. I think probably good just to introduce ourselves. So what we do. Our approach, and I think we will zooming into the topic of today, which is the techno-economic aspect of additive. So for us as a company, the angle to additive manufacturing has been supply chain optimization. I think hence the brief introduction and the short animation. We also would like to underline, I think, and Olivier also mentioned it, that and we'll get back to that in a few minutes. Additive manufacturing is not about the printer, but it's a process, and I think every step of that process is actually instrumental to a successful outcome. And for us, we also think that additive will enable an on-demand world, and again, some examples to underline what the importance and relevance is that in this time and age. Just a bit of background on our company. I think we have been recognized also by World Economic Forum because of the approach that we have taken to basically embedding 3D printing into an integrated supply chain. I think I was very pleased with the remarks Olivier, that you also just made about the complexity of a process, of the many steps, the many iterations. So addressing that has been the starting point of the Dymanex journey a number of years ago, because we saw what the complexity was, and we also understood that we had to fix this quite complex supply chain for manufacturing companies and service organizations. So what we strongly believe, I think, and this is just a little bit of background and to get you into the story, is that what we've done is basically solving the pain in the supply chain. I think this is a picture of a ship I think we've probably seen all over the world. And we saw also what the impact has been if things do not get to the place where they actually need it. So our belief has been to make a better supply chain and actually fix the challenges that I think everyone working in the industry, working at maintenance organizations, working at manufacturing organizations has been encountering. And what I mean with better, more sustainable, supporting a circular economy, improve service, rather, as I think Olivier, I think I'm just going to use some of your examples, rather than people waiting for 30, 40, 50, 60 days for something to fix or to repair, Additive can provide an immediate solution. Less waste because you only produce what you need. Mitigating risk, we've seen the examples, COVID, but also other events where, supply chains were disrupted. And obviously, I think more and more companies are starting to see that, additive can also, and this is the economic angle to additive manufacturing, can also provide a benefit in terms of total cost and an improved ROI. Because it's not seldom that we see that customers of ours have 60, 70% of their stock for service and spare parts not doing anything. So basically waiting to be written off and eventually to be scrapped, which is obviously waste. So what we've done, we made a new supply chain, not simply, but we made it. We made it on demand, which means that our customers can have the benefits in that, and we made it simple. And again, simple in relative terms because the complexity of additive, looking at the engineering, looking at the manufacturing process itself, the validation and approval in itself is not simple. But we've made it, we made it simple and embedded in one environment, ultimately to give our customers again control of their supply chain. Just to give you a feel in which industries we're operating and where the additive is being adopted. And I think these are some of the names are well known, but just to give you a feel where additive is being used at the moment. What I would like to, I think also as part of the techno-economic theme for today, additive manufacturing needs an executive perspective. Why? Firstly, additive is not about the printer, it's not about the engineering, but it is about the entire process from understanding what can be printed all the way to a delivered part which has been tested and validated. If a company, and whether you are a railway company, you're running a metro line or an oil and gas company, or you are a producer of gas turbines, I think if you have not worked out the details of such a process, it will be incredibly difficult to capture the value of additive manufacturing. And that's why it's clear that it needs an executive perspective, also because the value is not necessarily on the engineering side. The value can be in having less stock. The value can be in needing less working capital. The value can be in reducing your environmental footprint or providing a better service to your customer. So this is why I think we have recognized that, additive needs this executive perspective. So we've identified three domains. The first phase, because obviously always the question people get, what can you print and why should I print it? So, and here in these what and why, here is in those two words, we have actually enclosed the technical and the economic element. And I will give you a few examples of that later on. The second step of that journey is obviously once you know what can be printed, you need to digitize it. And I think Olivier referred to the digital twin. We've created a digital passport, which has a little bit more information than I wouldn't say just, but then purely the technical information, because there's more to it. And ultimately there may be a need at some point to have a part produced or printed anywhere on the planet. So this all of this, I think we have created to support customers, in their in their wish or desire and belief to capture the value of additive. What does the process look like? I think you've just seen the 13 steps. We have basically, you saw it in the short animation as well. It starts with data import. It continues by transferring that data into actionable insights. And I'm just going to share a little bit more on that. The actionable insights basically are being fed by two sources of data: technical data. So what can I print? Based on size, dimensions, function, tolerance, materials, but also why should I print it? Yeah, if I need one piece a year and I don't know when I would need it, but my lead time is 200 days, which is not uncommon in domains like defense, oil and gas, and transport sector. And I have a minimum order quantity of 200 pieces, that will definitely generate a lot of waste and storage. So in that case, this would be a very suitable part to be digitized and printed on demand. The rest of the circle, as you can see here, I'm just going to see if I have a pointer here. Yep. The rest of the circle here supports the phase of design, conversion, and approval. And I think here, and again, Olivier shared his experiences. I think we see with many companies, there are many handovers. So we build this in one workflow so that an engineer at the customer, but also an external engineer, can co-work in the workflow just to optimize or fix a part if needed, and ultimately connect the part to a type of printer, because also that, I think, it will make life a lot easier for customers, because not every company or customer has all the capabilities and knowledge to know exactly which type of printing technology, which type of material, and so on and so forth. So all of that is captured in the platform up to the routing, which basically means deliver the production order to the location that has the capabilities to do it, but not just the printing, also the post-processing. And then last step is having the part delivered to the front door. So this is where we actually the end-to-end flow, where we just explained, you need an executive perspective, because the reason to do this can be a multitude. It can be less waste, less working capital, reducing your maintenance cost as a business. So there's a multitude of reasons why companies do it. So here you see a screenshot of the outcomes of the analysis, and typically we look at hundreds of thousands of records of parts that companies keep as their spare parts, service parts, low volume parts. And just to give you a feel how we encounter the techno-economic angle in this example, on this screenshot, you see a part which is where all the technical information is stored up to the pricing information. So that's one angle, but this only tells me one thing, it can be printed and it costs X, Y, Z. Where it gets interesting is if you, for example, are able to see, hey, if I would print this part, then my immediate benefit is that I avoid waste. There is a comparison, what we call a lifetime cost estimation, where you can really see, how does it compare to traditional manufacturing? So let's say the traditional production technique was the example, where the part needs to be welded, compared to printing it now with a higher minimum order quantity. So getting a complete perspective on the technical and the economical side will help companies immediately, real time, to make the right decisions. So this gauge indicates by how much the stock can be reduced, or how much benefit you have in terms of lead time reduction. So there are multiple angles nowadays to do this. Very important here, and I think this was also mentioned by Olivier earlier on, is that companies have to basically step away from conventional thinking, because in the past, we were only looking at supply chain or only looking at the production technique. But by combining the two things, you can immediately derive what the value means for your business. These are a few examples. I'm not going to go into each of those, but these are spare parts, slightly bigger parts, which can be done through additive casting, a whole range of parts varying from aluminum, different types of steels, reinforced plastic parts, which all been printed, validated, and basically released for use. And this was for a defense, one of our defense clients. A good example where people always ask, what is the value of additive? Well, this is a great example because this unit would cost 1,000 euros. However, the only requirement was this this little piece. It is a seal which was ultimately produced out of a rubber-like material, a TPU, and that only cost, I think, 17 euros at the time. So just to give you a feel, in many cases, companies are forced to buy complete units where they actually can do with just one part. And obviously additive makes that happen and possible. Another example, and this is also techno-economic, and we'll explain why. The left-hand side is the traditional part, and the right-hand side is the optimized part. And you could say, well, different material, yes, but the other benefit is the weight reduction resulted in this production line that the line speed would go up and the cycle time was reduced, which basically means that for this particular client, the output per hour had gone up. Other example, optimization here, also weight. And again, I think we saw other examples earlier on. The weight reduction basically also allows for higher output per hour. And obviously you only need, with additive, you can create structures that cannot be created with traditional production technologies. This is an example in the oil and gas sector where sometimes the parts are damaged, they're being reverse engineered and ultimately produced and printed. Other examples, what also happens in many cases, and this is a very good techno, also looking at the two angles. The original parts consisted out of 4 pieces with 4 different tools. One of the tools was broken, but the customer still needed parts. So the entire part was ultimately printed out of 1 piece. So these are examples of how the technology, enables to fix all kinds of issues in the supply chain. Obviously, we don't do this in one, in all ourselves. We work with an ecosystem, and I think in the UAE we have a partner, Immensa, I think, which was also introduced, I think, for day 2, where Mr. Fahmi Al-Shawar will do a presentation as well. So we work locally very closely together with them, given their expertise in the engineering space, and we have cooperation with a large number of manufacturing facilities across the globe, knowledge institutions like VTT, Applied Science Institute in Finland, UL Lloyds and other companies, just to make sure that we're up to speed on the knowledge that is available. Just to wrap up, the key benefits, I think back to the key question, the techno-economic angle for additive, it will help companies and their customers to secure and increase uptime. It will reduce the demand for working capital because you don't need to stock up things that you actually don't need. You only produce what you need. What we have seen and learned that unpredictability is one of the, statistically also for supply chain organizations, to fix unpredictability, people typically buy stock because they don't want to end up in a situation that they don't have stock. So rather than fixing things in a conventional way, you can have a digital twin or a digital passport and print on demand. What you also see is that with lead times are typically a lot shorter. Minimum order quantity is 1. So basically you have the flexibility. And there is across the board a huge potential to eliminate waste, but also to contribute to a circular economy. And well, this basically is my contribution, and I'm looking forward to the questions later on. Thank you very much.
Thank you so much for that, Tibor. I really appreciate those insights as well. So between every question that I'm going to ask, the order will go from Olivier and then from Tibor's perspective. So from all the challenges that we face in the industry, whether it's the design aspect or the scalability or the financing aspect or the accessibility, which ones do you think are the top 2 that should be addressed quickest, or which ones do you think pose the biggest challenge and opportunity at the same time, based on what you guys have been focusing on recently?
From our perspective, the challenge that we see early in the AM adoption phase is the part identification. Is to say, okay, where and how do I find the right part to use for additive? Because this will obviously have consequences on the next step, which are rather the design aspects, the material definition, the feasibility, and of course the building a business case. Because there was a comment or a question from someone in the chat to say, yeah, additive is still expensive, but you have to see also beyond the cost of the part. You might end up with indeed an AM part that is more expensive than the current part that you have. But what about time to market? What about supply chain? It's all these aspects. So, and that's for us, the starting point is really a part identification, because it has an effect on the other steps that I mentioned, up to the business case, the validity of the business case for this application.
Tibor, you're up.
Yeah. I think for as I mentioned in the the introduction earlier on, I think what is fundamental is that there is a holistic there's an holistic approach, and there is a clear executive perspective on why they want to embed additive in their organization. I think we have been working also with some first cooperation with the team at ADNOC, I think, and one of their ambitions is to reduce the maintenance cost. So if you have a very clear target or a goal as a company, that is the starting point. And in my humble opinion, I think that the technology still has challenges, but if most of the time these challenges can be addressed and resolved, because we have a lot of smart people. There is great technology, I think, but as soon as there is a common understanding why a company wants to engage with additive, the rest will take time, but it will happen, because then there is a catalyst. And otherwise, people will rightfully come with questions. Yeah, but additive is more expensive. I think in many cases, it's clear if you take the full perspective, there's a lot of potential for additive in supply chains for many companies.
And if I were to flip the question around, what are you excited most about in the spaces that you operate in? Starting with Olivier.
And what are we most excited about?
Whether it's which industries that you have been operating in specifically, or any, let's say, major shift or acceleration that happened recently, which you think is going to be quite impactful on what's happening. I mean, you guys are operating within, not only from an additive manufacturing perspective, but let's say Siemens as an overall umbrella. You guys are touching across many different advanced industries, right?
Yeah.
You see the real adoption from the traditional industries versus how it's been over the past 2 years, for example. Where are we today compared to what's coming next?
I mean, the early adopters of additive, at least the ones who are using it at an industrial level, are the main drivers of aerospace and defense and the medical sector. But what's interesting in the last couple of years, it's, for example, the consumer goods industry. We see a lot of advantages. I mean, obvious advantages of additive for customization. So we have worked on projects, or we're currently working on projects, for example, to make customized helmets or glasses, or the footwear industry is really adopting additive manufacturing. So, and this different technologies, different kind of parts. So I would say, yeah, it's I wouldn't say endless potential applications, but the ones that I just mentioned are really interesting, because it's customization, but still mass customization. So that's a very interesting aspect we've developed in recently, last couple of years, I would
say. It's funny that you mentioned about the medical space. Someone from the audience asked regarding where do you think the adoption is for the clinical education and the lab perspective? So I guess there's a lot of advancements in that field.
Absolutely, yeah.
Tibor?
Yeah. Yeah, I think what we're most excited is that we have seen, I think probably, and I think there even COVID has been somehow a little bit of a catalyst in, how companies are looking at additive. So we've seen that also based on the part identification and the software that we have developed, we see a number of our clients, they're scaling. They started with 30, 40, 50 parts, and they have identified clear goals for themselves to digitize up to 1,000 or several thousands of parts and make them ready in this digital inventory for printing on demand. And before making that decision, we see that those particular clients, and I've shown a few of the names, they are basically making the business case using the analytics. So they can clearly see that they will avoid waste. They will no longer need to keep stock. So there are different, I would say, KPIs being defined by these companies to basically justify additive, not just looking at the production price, because that is, for us, that's the wrong starting point if you want to make an impact. And then I think secondly, in terms of where we see the biggest value is in industries where you could, and I'm just grouped them quickly, heavy equipment. I will also explain why. Companies that produce food processing and food production lines, because they're small, relatively small series, the importance of uptime is quite important. And we see also, and in addition within the cooperation that we have with Mensa, we see also traction in the oil and gas sector. So those are areas where there's a lot of traction because people can measure the benefit, the economic benefit and the technical benefit immediately.
And to complement what you just said, I think it's also applicable within the water industry. I know there's a lot of entities that we've been dealing with operating in the high pressure water that they're looking into this from this regard. Gentlemen, appreciate your inputs. We have run slightly over schedule, and it's been an insightful talk. Actually, I'm sure a lot of insights have been shared and kind of absorbed by the audience. Olivier, Tibor, thank you so much for your time and appreciation.
Thank you to you.
To the audience,
thank you for the opportunity.
Tuning in as well. Looking forward to engage and keep this going. Ciao, have a great day. And
thank you. Thanks for your time, everyone. Bye-bye.
Thank you so much.